My name is Jean-Charles, or JC Ledé. I'm with the Tactical Technology Office, where I focus on unmanned airplanes and autonomy. I also have programs with the Defense Sciences Office, where I do essentially the same thing, but at a more fundamental research level. The project is rapid 3D reconstruction using a commercial drone. The company that was funded under SBIR funding is Near Earth Autonomy. This SBIR effort is part of a larger effort in which we're exploring ways of utilizing systems that are available commercially and adding capability to them to make them more suitable to military needs. In this particular case, what we're doing is that we developed a small payload that is compatible with a number of commercially available small unmanned airplanes, also known as drones, and we are able to fly over a complex structure and combine the LiDAR data, which provides you a very high precision dimensional representation of the volume, with a set of images that are collected at the same time and then overlaid on top of the cloud points that form that high accuracy dimensional representation. So now you have the best of both worlds. You have an image that looks real because it's based on real images, but also a 3D representation that is high accuracy. So the right angles are right, the flat walls are flat, and you have none of the typical distortions that you see in commercially available representation of 3D. The other benefit is because of the combination of those two sensors, you really are able to do that in real time. So now you can imagine an operation where a small drone takes off, follows a path autonomously, and collects that data. By the time it comes back, our troops have a very high accuracy, up-to-date 3D model of the environment they're going to walk into. It allows them to detect potential traps, allows them to detect ambush or any kind of threat that may exist in the environment. We really enable new capabilities using what is otherwise commercially available technology.